So we saw that we could use the GeoBubbleChart command to display spatial data counts, attributes of particular cities, in other words, in the form of scaled bubbles. But there's actually a number of different ways where we can represent data on our maps, or geospatial information on the maps, and we're going to turn to some of those examples right now. Mathematica has an entity for historical sites, which have a number of properties: administrative division, area, cities, countries, coordinates, and so on. And we can request a list of historical sites in a particular country with a command like the following. So I've grabbed a list of historical sites in Canada. Each one of these sites is going to be a Mathematica entity, and we're storing that in the Canadian Historical Sites symbol. Now we can choose a couple of them to look at with a random sample command. So this gets into the list and it pulls out 5 of those. How would we know how many there are? Well, it's a list, so we can use the length command to tell how many there are in total. We use the geoposition command to get the locations of each of those historical sites, and we can store that in a list of locations. And once we have the information about where those sites are, we can create a geohistogram, which creates a grid of bins, and it counts how many historical sites, in this case, are in each one of those bins. Now the bins are, in this case, I've set them to be 250 square kilometers. I'm plotting it on a map of Canada, and the color of the bin tells you how many historical sites there are. And not surprisingly, we can see that there are larger numbers of them near Vancouver and Victoria, near Toronto, near Montreal. So this allows us to count the number of historical sites in a particular region and then plot them in this grid of bins. Again, it's also not surprising to us that many of them lie on the border with the United States. If we want to plot the actual locations, we can use Geographics, and what we've done here is we've put a small blue dot with 50% opacity, so it's half transparent. We've put a small blue dot at each point where there is a historical site. Like here, there's a single historical site. We can see that the blue dot is partially transparent. The reason we use partial transparency like that is because when we stack up multiple copies, the color of the blue gets more intense. So if there are a number of historical sites close together, as there are in this region, then the blue is going to become darker and darker. Now Mathematica has a command called show, which allows us to superimpose multiple graphic images on top of one another, and that includes maps. So what we do next is we use the show command to put the bin information down first, and then the point information, and then we can see not only the intensity of the sites in a particular location, but also the sites themselves plotted as these little blue dots. If we hover over a particular box, or a particular region. Here, for example, we can see there are 114 historical sites. Here there are 69 of them. Out here there are 29, and so on. Now another kind of information that we can plot on maps is elevation. In this example, we're going to a popular skiing destination. That's Whistler, a city in British Columbia. We ask for its elevation data. We turn it into an amount with quantity magnitude, and then we can use a command called relief plot to plot the mountainous area by this ski resort. If we want to see topographic contours, instead of relief plot, we can use list contour plot, and we say we want 20 contours. So that's another alternative for plotting areas, especially ones with significant relief like mountain ranges. And in this case, the data that's associated with each point is its elevation. We can also plot populations in a similar way. It's not surprising to find most of the Canadian historical sites near the US border because most Canadians live quite close to that border. Here's a command that retrieves the largest cities in Canada. They're sorted in order of from largest to smaller. So Toronto, the largest city, Montreal, Calgary, and so on. We can ask for their associated populations. 2.7 million people for Toronto, 1.7 million people for Montreal. Now this information is in a form that we can directly plot with GeoBubbleChart. So here are the cities in Canada with the size of the bubble scaled to the number of people who live there. And one of the things you can see if you're familiar with Canadian geography is you can see the large ring here for the city of Toronto, but there are also a number of other large cities in the greater Toronto area. So one thing that we might think of doing is not plotting the city per se, but plotting metropolitan areas instead, which would give us a different map. Another example that we can look at is historical crime trends in the United States. This example is simplified from a version in the Mathematica documentation. There's a link to the Mathematica documentation version too. We can use entity properties to request crime rate if that's available for a particular place. And this next command uses select with entity properties to pull out all of the properties that have crime rate as part of their name. So total rate of property crime, total rate of violent crime, and total rate of crime. Now we can plot these for a particular region with what's called date list plot. So what this command says is it says give me these three values for Alaska, and the dated command here says give me all available dates. And we can see that from 1960 to the 2000s, crime increases to a point in the 1980s and then generally decreases, perhaps with a bit of an uptick more recently. Now, in addition to all crimes like that, or all crimes of particular classes, we can also retrieve rates for specific crimes. So this next map is a map of recent motor vehicle thefts in Atlanta, Georgia. We plot the choropleth to show the number of crimes in each administrative division, and you can see that we have data for some places but not for all. That explains the patchiness of the map. And we can also see that this particular kind of crime is concentrated in specific places. We can create a map of total crime rates for each of the states in the United States, again using geo-region value plot, and this gives us a map of crimes per person per year. These are contemporary data, but we could also ask for historical data. So for example, we could ask for the number of crimes in California. Right now it's at 0.02946. In 1970, using the dated command, we get a rate that's more than twice as high. Now, one of the really interesting things about using Mathematica for research tools is you can build interactive interfaces right inside of your notebooks to explore things. And that's what we're going to do in this next section here. What we do is we're going to create a interactive interface that we can manipulate by sliding a timeline for a year. And the way that this works is we start with a table, and we get a table of the years from 1990 to 2015 counting by 1, and that looks like this. If we simply replace the word table with the word manipulate, we end up with this interface that allows us to slide back and forth on a timeline. Now, if we had a map for each of those years, we could use this timeline slider to navigate that map. And that's exactly what this next command does. It uses manipulate, which is quite similar to table, to create this interactive map where we can explore the map of crime for a particular year. This little plus sign gives us more options. This is 1990. We can step forward one notch with this plus sign here, and it will take a second to compute. There's 1991. Step forward again. Here's 1992, and so on. We can also drag the slider to get to a particular year and see how the map changes over time.